All right, so as you can see here, we have two graph problems. Our first is a graph of velocity versus time, and our second is graph of x versus time, and thus displacement versus time. So for the first problem here, this first graph, we're going to just focus on calculating the acceleration for each of the segments. So you can see the segments are all straight lines, which is good, because otherwise you need calculus, but also they're labeled A, B, C, and D. Now, if we want to find, what we can find from the velocity versus time graph is the acceleration. And the acceleration is going to be the slope. Okay? So, if I want to find the acceleration of each of these, I can use our standard slope formula, which would be y2 minus y1 over x2 minus x1 m. And what this actually ends up being in this case is that the y values are v final minus v initial, and that's over time, because the x values are time. All right, and that's essentially how acceleration is defined. So for segment A, we can solve. We see that it has a change in a y of 1, or change in velocity of 1, and a change in time of 2. So it's 1 minus 0 over 2 minus 0, or 1/2. Okay? Go a little quicker. B goes from 1 to 3, which means it's got a change of 2. So 3 minus 1 over, and it goes from 2 to 4, so 4 minus 2, or 1. C is going to give us going from 3 down to 2. Now what that means is that instead of it being 3 minus 2, it's actually 2 minus 3 over, and then this one's going to be 8 minus 4, and we get negative 1/4. Okay? And then D, we have, it starts at 2 and it ends at 2, and so we just come out with being 0 over 2, or 0. Now what does this negative sign mean? Well, the negative sign in a problem like this is just going to indicate, again, direction. We decided that whatever direction it was going initially, okay, it was positive, and eventually it started backing up. That's negative. All right, so now we're going to look over at our second problem here, our distance versus time one. And here we're going to do a couple of slightly different things. First off, we're not going to do the calculations, at least not initially. We're going to try and put them in order, from fastest to slowest velocity. So, and then fastest to slowest time, speed, sorry. So for velocity, okay, we have, which one's the fastest velocity? Well, there's two things we got to consider. How steep it is, okay, because more steep means greater slope. And just a quick reminder, if you have distance versus time, velocity is the slope. The second thing we need to know is whether it's positive or negative. In velocity, positive versus negative matters. So we're going to start with the one that's steepest going up. And that's pretty clearly segment A. Okay? Next we have the only other one that's going upward, which is C. Finally we have B, and then D. Now it's not totally obvious that D is, it's a little bit clear that D is steeper than B. If we have to, we could then do the calculations. But it turns out that, of course, D is steeper than B, but D is more negative. Therefore, B is greater than D. Now for speed, it's a little trickier. Okay? Now we're not worried about whether it's up or down. We're just talking about what is steepest. Okay? So we have to kind of consider here and be like, A and D are close. Okay? A goes up 4 and over 1, and D goes down 4 and over 1. Turns out that means they're both the same. So we'd actually have A is equal to D to start out, because the object's going to go fastest during those times. We would then have B as a steeper slope than C, so it would end up like this. Okay? All right, that's it.